friends, today I, Gaur Krishna, would like to talk on the topic the language of chemistry, ICSE class 9 chapter 1. So today we will talk about this chapter. So starting with the first topic, that's language of chemistry. As we all know, for physics we have the language mathematics. So here for language of chemistry, what is the language of chemistry? Okay, so starting with that, we should know what is matter, a basic concept given here. Matter is something which occupies space, and element. Element is the purest form of any atom, or you can say similar atoms when grouped together form an element. Okay, so this is an element. Now, next topic is molecule. What is molecule? Molecule is when two or more similar atoms is combined together, and that is a molecule. And molecule can be of many types. Like you can say diatomic. As the word suggests, it is di meaning two, and atomic means atoms formed together, and that is diatomic. The second is triatomic. Triatomic means, as the same word suggests, tri means three atoms. And when we come to tetraatomic, as the word suggests, it's four atoms. And the last is octaatomic, meaning that there are 8 atoms in that molecule. And we spell it as OCTATOMIC. As many people have confusions over there that there should be double A or single A. So there should be single A, not double A. Okay, so starting with this. Now, when Dalton in 1808 had given all these many postulates of atoms, at that time there were not any symbols of that. It was like a circle, as I can name of some, like for hydrogen, it had given a very simple symbol, a circle and a smaller circle with all its area covered. Like this, you can say a circle with a big point here. Like as we can see here, it's a circle and a small point. And of carbon, it was a very unique one. It was the whole circle was like this. Whole circle was colored, and that was of carbon, the main symbol of carbon. Okay, so with this, but when as slowly many elements was discovered, then on the basis of shape we could not give more atoms at their name or symbol. So therefore we need something. We needed the IPUAC. The full form of IPUAC is International Union of Pure and Atomic Chemistry. And here what he did, it was very simple. They named it. And how did they name it? They named it on the basis of atoms, protons, electrons and neutrons. So that we would talk today. So like you can say gold has a very unique name, AU, and you think that it's exceptional. No, it is its Latin name, as we have names like a German name like tungsten. Tungsten in Latin is something else, but we name it as W because in German we call it Wolfram. Therefore we say it's Wolfram and W as its symbol. Okay, it's like gold, copper, silver, mercury and many more metals. Okay, so these were now in 1814 only, the Birch release suggested that a simpler system of representing elements we needed the simpler system, and for that we needed iron, IPUAC. So that we will talk now. Now it comes the valency. Valency is a very much important topic. Valency is nothing, but they have to say that how many you can see the number of valency. We can define that the number of hydrogen atoms that which can combine without displace one atom, as, or you can see the number of atoms left in the last covalent bound or valent bound, or you can say the number of atoms which are not able to combine. So the valency of all metals and hydrogen is always positive, that is 1, 2 or 3, and that of all non-metals are always negative because they are around 4, above 4, 5, 6 and 7. As we now here can see, 5 can be written -3, 6 can be written -2, and 7 can be written -1. As example is chlorine. Chlorine is atomic number is 17 and it needs 1. As we cannot give 7 electrons to another atom, but we can take 1 electron to chlorine atom, so therefore we have to give something. So therefore chlorine or non-metals are considered as negative. Okay, so now combining atom. Here in valence, how to combine atom? So we can combine atoms of like 1 atom of hydrogen, 2 atoms of hydrogen, or 3 atoms of hydrogen. These are combining forms, and we can these are the combining forms. And like example, potassium chloride, KCl. Here the potassium one is electrically positive. Why? Because it has given 1 electron to chlorine and therefore it is positive. So we would write 1 plus. And chlorine is negative. So we would write 1 minus as it is negative. Because a plus 1 and 1 minus. We write this here opposite signs. And so KCl. But we don't, for in short, we write only KCl as its symbol, as we don't write its positive, like potassium is electronically positive and chlorine is electronically negative. So the next comes is the variable valency. So what is variable valency? Like we can all like potassium is K. So we know that what is potassium's valency? It's 1. So variable valency of K would be +1, and variable valency of Cl would be -1. Not +6. +7. Why there is a difference between -1 and 7? Because we cannot give 7 atoms to another like any atom. We said radicals. What are radicals? Radical in simpler terms, you can see that there is a group of atoms or elements that behaves like a single unit. Like radicals. Now we are defining these radicals as molecules, and like these molecules, like many similar atoms to like I just now said that octatomic and diatomic, triatomic, tetratomic. There are many types of atomic molecules. Okay, so chemical formula. Chemical formula is a simpler thing. It's a formula which there is a molecules of a substance. Either they are elements or compounds, not mixtures, because mixtures are never in a fixed ratio, but compounds are in fixed ratio and elements are the purest form of atom. Okay, so starting with that, we know that chemical formula is a molecule of a substance. Yes. Now starting with that, valency chart. What is valency chart? Valency chart, in simpler words, we can define that it is that I am giving you an example. Like I said, for always I give an example. Potassium, K. Okay, so K. This K we can write 1 plus. Always. So this is the valency chart, and then we would write the sodium. We would make a chart. In a simpler words, we can make a chart. And how we would make a chart is very simple. First you write sodium, then potassium, then chlorine, and many more. Chlorine, copper, and like this. It would be the first would be the name column, where we will write the name, and the second column would be like sodium is Na, potassium is K, chlorine is Cl, copper is Cu, and then we would write all the valencies. Valency, like it would be 1 plus, it would be 1 plus, it would be -1. Like this we would write, make a valency chart, and that is known as valency chart. And now how can we name them? Like permanganate, I can say sodium permanganate. What is that? Or sodium metal aluminate. Now how from name, how can we make that chemical symbol or chemical formula? That we would now going to study. So I am giving an example like sodium metal aluminate. Okay, that now we know sodium, that is Na. Metal means that it is a metal. Yes, sodium is a metal. Okay, fine. Aluminate, aluminium means Al. Okay, Al. 8 means O2. then we have now here, therefore we have found that what is sodium aluminate, that is AlO2. And now how would in valency chart we would write that sodium is 1 plus AlO2, that is -1, and therefore this is the main thing, but in short we only write NaAlO2. Okay, like we said, carbon dioxide, how they we formed. Today we are going to study this. So one more example, it is nitrate, sodium nitrite, sodium nitrate, sodium nitrite. First, sodium nitrite. Okay, sodium nitrite. Sodium nitrite is sodium, as we know, Na. Nitrite, as the word suggests, if the simpler we can write directly nitrite as NO2. Okay, so now we know now we are going to study that what is the valency. Sodium always is 1 plus, and NO2, if this is 1 plus, then this O is oxygen, and oxygen would be all, so here it will be 1 minus, as this is 1 plus, it is 1 minus, and when we would sum it up, it would be always 0 or 8. 0 or 8, then only it would be like a good, it would be formed. Okay, so now divalent elements. What are these divalent elements? These are when there are two electrons left. Example, sulfite or sulfate. I can say sodium. Okay, so I am first taking sodium sulfate. Okay, so here we know that sodium is Na, and we have to balance this equation also to form an good compound. Okay, so we are here taking sulfate, and sulfate is SO4. Okay, so SO4. Here SO4 would be when we calculate the number of atoms as S sulfur and O oxygen. Oxygen is 6, meaning it has 6 atoms left, and it needs 8 atoms here. And the sulfur can provide these atoms, but it needs 2 atoms. So the chemically formula, it would be 2 minus add SO4, as it needs 2 atoms. And here sodium only so sodium can provide only 1 atom. So it is not chemically equal. It would be like it is not chemically equal. So therefore we will write 2NaSO4. Or we can write this is not right. It would be Na2SO4. Na2SO4. Then it would be chemically right. Okay, so it was tetravalency. Here it was 2 electrons. Here it was 1, and it can be of 3 also. 3, it can be like I can give one example. Manganese. Here we can write manganic. Sodium manganic. And sodium manganate will be Na3, 3 below, and manganic means Mn. And here, as we can see, there are many. Next form. Now, how can we write these? How we interchange the valencies? So, starting with the very basic one. That is H2O. H2O, we all know what is H2O. So H2O, as I am giving an example. So how can we write this H2O? We will write this H2O like this. HO. And above H you would write 2, here you would write 1. So number of atoms to find out, we have to simply, here it would be 2, here it would be 1. And as I said, it is very simple, and therefore it is H2O. Simply we can say 1 atom of hydrogen, 2 atoms of oxygen. Now this is how we form a chemical formulae. Now rules in naming certain chemical compounds. There are rules everywhere, and here for a metal and a non-metal we should write the metal first and then the non-metal, like NaCl. We always say sodium chloride. Okay, we don't say that chlorine sodium. That would be wrong. First metal